Now, if you weren't with us on day one yesterday, just a quick reminder that Tapper EMEA's annual conference is following the Chatham House rule. This basically means that you are free to use information from our conference sessions, but not allowed to reveal who made any specific comments without their prior permission. So thank you for following that. Now, we've heard throughout yesterday, and we will be today as well, various references to AI. And now it's time to delve a little deeper as we hear about Amazon's journey to leverage AI for asset protection and physical security. And here to tell us a little bit more, and in a slight change to the program, are Andreas Siedel, Amazon's Regional Director of Security and Loss Prevention, and Stefan Levy, CEO of BeamUp. Please join me in welcoming them to the stage. Thank you. If you can finish by 10:30, that would be great.
We try. Okay, good morning, everyone. In the interest of time, so we skipped the first 20 slides. We just have been told that we have to stop at 30 past a minute. No, we will do this. So just as close as possible. We will try our best. So welcome, everyone. Big title, big discussion behind this. And I'm glad that I'm here with Stefan as the CEO of BeamUp. And this is one of our largest partners. So what we try to achieve coming out of COVID, out of a period of significant growth, where a lot of costs that everyone had to introduce in their supply chains in order to meet customer demand, we as an organization were faced with a lot of pressure on ensuring speed, quality of delivery, while looking at our costs. And doing this, we always had to ensure that we are compliant. They were reducing times that it needs in order to add to our topography, which meant for us building new sites across a region in new risk environments, and also developing new designs. So when we did this, we had the challenge from Gilad, okay, do this with the same amount of people that you have, but deliver way, way more. And do this in order to ensure that we have a safe environment for our associates, which is prime for everyone at Amazon, and also focus on the security of the goods so that we can deliver to all of our customers. What it meant for us coming out of 2022 with 4.8 billion units being shipped out of our buildings, which means roughly 56 units being shipped per second outside of a peak season, more than 86 units in the EMEA region being shipped during the peak season, with one van leaving one of our sites each and every second. You can think about what it meant for a tech company like us, which is heavily focused on data. What do we need to do to scale this? Can we do this with just our own personnel that is sitting behind the screen and analyzing data? No, we needed to invest in tech. And we needed to look for solutions which are going beyond and help us to find new correlations. And this is what we try to do in the next thing. So I'm handing over to you.
Hi, everyone. As Andreas mentioned, I'm CEO and founder of BeamUp. We're a startup with the mission of bridging the gap in between the physical and digital worlds. We leverage AI to help the world's largest organizations to aggregate their data, automate their processes, and generate insights to transform their operations, asset protection, and physical security. Andreas just described some of the challenges that Amazon has faced as they deal with the issues of scale, and I'd just like to quickly elaborate how we see this at a more abstracted level.
So yeah, thank you. For a lot of us here today, we know that scaling of assets, so all of you most likely have huge amount of ASINs, or huge amount of individual items that you store in the locations and that you have to move. And for us, this asset means a lot of shipments, multi-shipments, where we have different articles in the same box, as well as a lot of you that sometimes like to just receive one box of an item. For us, this is scaling it up with 2.5 million different units in one of our buildings on average. We call this the scale of the assets. And if we're looking at this from just a simple under-the-roof perspective, it means that we have a multitude of different risk vectors that can be attacked. So we're talking about insider threat, and we heard about this the last days in the last presentation, which is focusing on internal collusion between malicious actors, employees within our works. We're thinking about the risk from other parts of the supply chain, starting from disruptive events, natural hazards, terrorism, as well as down to counterfeit. We would actually call this the scale of risk.
These first two scales and first two challenges are also then compounded by the scale of organizations who have hundreds or thousands of locations and points within your supply chain. This is the third complexity, which we could call the scale of your footprint. When you take the scale of your assets that you're trying to protect, the scale of your risks that you're protecting against, and the scale of your footprint, this is complexity to the power of 3. Asset protection for large global organizations is truly a 3-dimensional problem. For all of those in this room today charged with the function of protecting your business assets, you have a critical and complex function in your organization. Despite all the attention that cyber gets these days, I would posit that physical asset protection is more complex than the protection of digital assets, and arguably more important as well. But there's a disconnect. The more complex the problem, the higher the scale, the more risks, the more data and automation that ought to be required. In other words, combating problems and challenges of scale with solutions built for scale. And yet, asset protection and physical security lags years behind the cyber function in this regard. How many cyber teams do you know that primarily rely on Excel spreadsheets and BI tools, as we see is still common in this space today? To flip things around, how many cyber teams do you know who are not using AI to automate their processes and proactively identify and manage their risks? Manual approaches around data are not equipped to deal with the complexity of this 3-dimensional challenge. They result in 3 significant consequences. First, data silos. Data generated in the real world is like the world itself. It's messy and it's imperfect. Eliminating silos and merging multiple data sets together would require constant transformation, cleaning, and structuring of that imperfect data generated by our imperfect world. You could achieve this, but with a manual approach, you would likely need hundreds of data analysts on your team. This is, of course, not feasible, so you learn to accept the data silos and accept them as a fact of the world. When you think of the multitude of data around the supply chain, from your inventory and warehouse management systems, your video cameras, your access control, your transportation tracing, RFID systems, incidents, local crime levels, terrorism threats, and myriad other sources, how many repositories in your organization does this data sit in? It's called a supply chain, but from a data perspective, I imagine at least some of these chains are broken within your organization. When you have silos, you are making decisions about this complex 3-dimensional problem that we could think of as a cube, not just in a 2D dimension, but from a limited slice of a 2D picture. Second, whenever data is generally, the data that is available is analyzed in a manual way. Some things are very manual. A TAPA auditor that literally requires a physical inspection at a site to gather the requisite information. Then we have the semi-automated approaches of BI solutions. But even the most proficient and capable BI teams and analysts cannot cope with the sheer magnitude of data around risk and supply chains. And a final observation on the theme of this conference, resilience. Resilience requires foresight. We need to anticipate our risks, strategically manage our resources and investments, and adapt and innovate to enhance our capacity to withstand and recover from adverse events. But when you operate in the world of manual processes around your data, I will argue it is extremely challenging to have broad foresight. Siloed manual processes produce an incomplete and static snapshot in time of a small sliver of the complex and 3D challenge in which we operate and which continues to evolve. The insights that you receive from manual processes are always out of date.
So the question that we had, so when you're dealing with complexity of scale, in an environment which is continuously changing, where you need to really move away from a heavy manual labor focused process to a more automated process, we're asking ourselves, what is it that we should do? So as an organization, our vision was to bring together the technology and sophistication of the digital world to the physical world, basically matching virtual and physical handshakes in order to validate them. In other words, we try to leverage the cyber tech stack in AI to build a solution of scale for our challenges of scale. And to transition from data silos to integrated big data. Sorry, I need to read this because I'm studying political science. I was never thinking that I speak about something like this in the time that I'm here, but I learned a lot about this thanks to the team, and I just don't want to take away. And from linear data analysis to automated insights, and from reactive, and this is for me the most important thing, to go to a predictive, and in the future to a prescriptive analysis will help us to solve.
So the question is, how does AI help us achieve this? The common definition of AI is the field of technology that allows machines to perform tasks normally performed by humans. I've already alluded to this, but I think that this definition is wrong. The reality is AI could perform certain tasks that we as humans would struggle to complete efficiently or would struggle to complete at all. If we return to some of the challenges that we outlined around data within the supply chain, we could look at how AI could help. First, in terms of the silos, AI could automate the process of mapping, transforming, cleaning, and structuring the imperfect data generated in our world, making something that is otherwise time and resource prohibitive with manual processes suddenly achievable. Furthermore, unlike BI queries, there is more flexibility as the data does not always need to be consistent or perfectly structured, since deep learning models understand data within context. For all of you who have tried to use ChatGPT, think when you ask a question and it's really mangled grammatically and you have tons of spelling mistakes and typos, and it still somehow manages to understand generally what you meant to ask. We spoke about manual data analysis. AI excels in processing large volumes of data in real time and performing the same tasks with consistency, with standardization at scale. That's something we as humans simply cannot do. And we spoke, and Andreas mentioned, that the most important step is to move from a reactive posture to a predictive, proactive posture. Deep learning models are adept at discovering hidden structures and patterns within millions of different data points and uncovering complex, impactful, and forward-looking insights about our environment and our world. AI systems could learn from data and improve over time without human intervention, adapting to new trends and patterns. AI helps us break down silos, leverage your imperfect data, process data in real time, and start predicting future events, all at scale, all without more resources. However, it is crucial to note that while AI excels in these areas, human intelligence remains unparalleled in other domains. In my opinion, ignoring AI and its capabilities is a mistake, but only relying on AI is equally misguided. We need to think of AI not as a replacement for us, but a complementary technology that steps up our capabilities and empower us to focus on more complex and creative endeavors.
So you heard us now talking a lot about the problem, the risk, the potential solution, but we start off with saying, like, what is the Amazon journey of this? And so looking at it, what did we start off at Amazon? We started with a small problem which we tried to understand and to master that truly enabled business speed. And everyone knows how cumbersome it can sometimes be to develop a design which is dedicated to a specific site in a new environment. A lot of risk assessment needs to go in. You need to have a lot of conversations with different SMEs, so subject matter experts on how to install, what is the rear camera focus, where do we need the sensors, how am I compliant to all of the country regulations from a retention time perspective, from what can be covered from a camera, what are the doors looking like, and what is actually a door. Now, what we started off with, Stefan and the team, we started off moving our 2D floor plans into a digital version, which we could easily utilize and have analytics running through all of the different requirements, learning what are our regulations, what are our requirements from a safety perspective, GDPR perspective, and how do we address standards, even like the TAPA standard, and to bring it in. And how we do this. We started off with a couple of weeks' times needed in order to provide the design, and we are now at the point that with one click, a design is ready in a couple of minutes. This enabled truly business speed by providing the business with the flexibility to react to different challenges during a startup, and helped us to ensure that we have a fully compliant environment within our buildings, even changing something small as a door, which might result in a non-compliance from a safety standard. Going back to what I said initially, the safety of our associates is our main priority, and then comes in the security. Now, just thinking forward, fast forward, even if TAPA would change a standard tomorrow significantly, which would require a different setup of cameras and coverage in certain areas, the information is uploaded to the system. With one click, we would immediately know how can we change, or what is it that we have to change in order to remain compliant and want to do this moving forward. And it could also provide auditors now with the right solution to validate that our physical security layout is in line with the standard requirements.
This was achieved and marked a successful first step in the journey in our collaboration and partnership together. But design's just looking at what the controls are. Are they designed correctly, and are they in place? But if you take that a step further, how do they operate? Are they operating correctly? Are they performing as you intended? According to the unique characteristics of each site and a dynamically changing risk environment, do you have too few or too many controls? What risks does the future have in store, and how could existing controls mitigate them effectively or not? Therefore, on this base of the digitized models of existing buildings and new buildings that Andreas just mentioned, in the next step of our journey, we started to layer additional sources of data from an operational perspective. As you could see here on the right-hand side, our platform started to aggregate data from a multitude of sources: shrink and inventory, risks, workforce and guarding, access control and video systems, maintenance ticketing, and myriad other sources. All of these multiple data sets were moved into and merged into a single data set, a single data lake. The cleaning and transformation performed automatically. The chains of the supply chain data reconnected and reestablished. With all of the data connected, Amazon could start to look to use other AI models to automatically generate insights, both at the strategic and operational levels. Now we'll take some look at some of the examples of the types of insights that could be provided once you connect the data and once you use AI to analyze that data on an ongoing and continuous basis. And just as a quick disclaimer, none of this data that we're going to show now is real Amazon data, which is of course highly confidential. These are just illustrative examples of the concepts of what could be achieved. The idea is to give you some ideas of how this approach could potentially benefit your organization. When we say insights, what do we mean? We mean complex information distilled into an identification of an issue first, a recommendation second, and third, a prediction of what the impact will be in terms of mitigating risk or financial ROI, those three elements. And what the system does is analyzing all of that connected data continuously and at scale and distilling it to textual insights like this, that in 3 or 4 lines, you could identify the problem, understand what a potential solution is, and understand the impact of the solution. So we could look at this from a variety of different perspectives of use cases. The first one's managing your assets. As we said before, standards are a baseline, but the world is dynamic. So imagine you've deployed hardware or controls according to TAPA's standards, but something's happening with your hardware once it's deployed. For example, you have an asset that's failing at a high rate across dozens of distribution centers. Will everyone at the local site level understand this and join the dots to connect and understand that this failure is occurring at scale? or will they only understand what they see in their own isolated space of a site level? In this insight example, if it could be read from all of you in the audience, a specific outdoor camera in a trucking yard is failing. And if the asset is failing, you are not in compliance. And the system understands that this asset is only failing in specific climate environments. It therefore gives the recommendation to change the hardware specifications in these specific cases. There's also a prediction of how much money you will save in unplanned maintenance by making this change. More broadly, you could start to begin where your assets are at a granular level. What camera is connected to what switch? What reader is connected to which board? What's end of life? And if remediation is required, for example, a standard changes, as Andres mentioned with TAPA, what is the cost going to be? All of this automated. Let's talk about a second use case about activity data, and let's also link this to the world of TAPA. I believe a TAPA regulation is that if you have more than a certain number of people accessing a high value or high risk area, you require access control. So imagine you've deployed that access control, but how is that access control working in real life? Who is analyzing that transaction data? Many of you come from large organizations. Imagine you have 200 facilities, and in each day you have 100 access denied events. That equals 20,000 access denied events a month, every day rather. That's 600,000 every month. That's too much data to analyze using traditional methods. Imagine 99.9% of those invalid access transactions are innocent, but that still leaves 0.1% or 600 events that are potentially malicious every single month. In this insight, we could see that in the past 3 days, there's been anomalous activity involving access denied events within a certain nighttime time period to the high value good area. This may be suspicious, but you don't want to be flagged with the noise for every single pattern of invalid access. But the system also knows that there's been no corresponding PIC tickets during this period. So the recommendation is to review the transactions and to review specific cameras that the platform understands is looking at this area. Think about the data that needs to be tied together to generate this type of insight. Access transactions, contextual knowledge of the layout of the facility and where your high-risk areas are located. What the reader is granting access to, where PIC tickets are issued, which cameras are looking into specific areas. Tying and analyzing this data provides continuous security, helping protect inventory and helping to protect more generally against insider threats.
Next one is guarding. And we all know manned guarding or guarding services, let's put it like this. Guarding services are a major cost for all of our organizations. But a question mark of, are they performing efficiently and to understand their impact in terms of mitigating risk? The challenge here is we need to tie together different streams of data with the understanding of the unique layout and characteristic of each building. We need to think about sizes, walking distances, and so on, as well as operational data such as alarm response times and shrink data. We, as an organization, manage so that we are now in a position to normalize data, truly benchmarking guarding effectiveness, and identify inefficiencies and understand correlation between guarding and risk reduction, which truly enables cost savings for us in an environment where we know the guard demand is going up, the availability of guards is going down, whilst we have to struggle to find quality at an acceptable cost within the market.
And to take a final use case, what's the relationship between controls and risk? If you deploy certain controls, could you predict what the impact will be in reducing your risk or reducing your shrink? What will the financial ROI be? What will the effectiveness be? Do you know if you deploy more security cameras, if it will only be effective at protecting against shrink of certain product types, certain product categories? Will it work across all of your business units in only certain facility types, maybe only certain geographies? With the power of AI and the power of connecting your data and the dots together, the next step in this journey is to start to make these predictions. That when you deploy a control, you could predict in advance what the impact will be, and what the ROI will be for your organization. And if you could take it to even a step further to start understanding at the individual SKU level, businesses could make different decisions. Where do you store individual items in a given facility? Maybe you should store them somewhere differently. Maybe they should be routed to a different facility altogether. Taking action in advance based on the predicted risk. And insights, of course, are not only limited to theft. This type of process could give your organization greater understanding more broadly about shrink as it relates to process-related issues. Something goes missing somewhere in your supply chain. What are the root causes, and how could you rectify them? And just to conclude with the use cases, aside from the analytic dashboard view, merging multiple data sets together and digitizing your facilities and connecting all the dots of data together really empower the local teams working in your sites and facilities. Amazon's now in a position where their local teams could see all of their assets in a model of their buildings to understand where are they located, how are they performing, what's operational, what's non-operational, where do I have maintenance tickets, to heat map various data points of interest, for example, shrink, of being able to understand where the shrink hotspots are in a given facility to empower local teams to generate their own insights. You have shrink occurring at specific points. We're helping to find those needles in the haystacks and then understanding why is that occurring. Is there an obstruction? Is there a lack of controls? Does this specific point in a warehouse or distribution center happen to be close to an exit door or other type of egress from the building? When taken to the field, you could maybe discuss what the results were.
So, as I said at the beginning, we are operating at a large scale. So even small investments and the amount of items and volumes we are pushing through the network can really create significant ROI. So for us, throughout the first pilots, we achieved with this solution a very compelling ROI, right? And we say it's larger than 1,000%, which is true from an investment that we had to do in the solution. We couldn't have scaled this with a heavy investment in labor or additional analysts, additional software developer, like business intelligence engineers, let's put it like this. We couldn't have done it without AI and relying on AI. This enabled us as an organization now to truly scale this throughout the EMEA region and throughout our global network in the next years. We will continuously push the boundaries and try to find with our partners within finance, retail, operations, new use cases, how we can utilize this to enable our operations to be more efficient and effective, while it's ensuring that we are all operating in the most safest environment that we can offer for everyone. So this including also all of the logistic partners, our guests, our associates, as well as other vendors operating on site, so that nothing is happening. I think it's one more, right? There we go.
So Andreas said this is just the beginning of the journey with Amazon. I believe we've already achieved impactful results, but one of the things we've learned from working with Amazon is to continue driving for continuous improvement. I think we've already started the journey of moving beyond the hindsight of manual processes around data and to a predictive, proactive posture. We're already thinking of the next stages. What more data could be aggregated? What AI models could be leveraged to generate even more powerful understandings of risk and predicting future events in our dynamic world? Perhaps, for some of you in the audience today, you're already in total control of your data, your operations, and your risk. For those of you who are not, perhaps some of you are content with the status quo. But for those of you who are not, AI presents a major opportunity as a leader in this space to think beyond how things have always been done in the past and to forge new ways of working. Big data and AI seem scary. It seems complex, but it's not. It's our world. It's our assets. It's our risk. It's our physical footprint. It's our supply chains that are complex. I'll end with a slightly adapted quote about complexity from Alan Perlis, the American computer scientist known for his pioneering work in computer language processing and the first recipient of the Turing Award. Fools ignore complexity. Pragmatists suffer it. However, for all of us in this room striving to innovate and think of better ways to protect our supply chains, let's work together and strive to remove it. Let's take our complex three-dimensional challenge and use AI to our advantage to create simplicity from this complexity, to connect the dots and distill information so we could make proactive and strategic decisions, so we could deliver value to our organizations and achieve true resiliency. Thank you for all of your time, and I look forward to continuing the discussions in the rest of the event.
Thank you.
Andreas and Stefan, thank you both so much. I've got a couple of questions. If you just stay here, as you've both got mics on, and I'll stay here, thank you. No, if you stay up here with me, that's perfect. Yeah. And also, if anybody does have any questions from the floor, please do raise your hand so that we can see you and get a microphone to you. Stefan, let me just start by asking you one quick question. What would you say are the prerequisites for a company looking to embark on AI?
I think two things. One's a culture of appreciating data. If data is important in the organization and informs the way that decisions are made, that's the first prerequisite. And Amazon, as everyone knows, is an extremely data-driven organization. The second prerequisite is some type of BI infrastructure in place. We see BI teams as natural collaborators and the foundation on which you could build an AI initiative. If you've not taken even the preliminary steps to start bringing the data together and analyzing it in some way, then I think it's premature to move to an AI initiative.
And Andreas, Amazon is clearly a very innovative company. What would you say is the potential for AI within the Amazon security landscape, and what timescales would you be looking at?
So for us in the landscape, it will unlock the new potential of really providing a truly secure end-to-end supply chain environment which is resilient, which is valued by our operational partners as well as by our customers and vendors and everyone using it. And so just continuously limiting our thought processes in an environment which is ever-changing, which is highly complex, AI will help us to make that next step into that predictive as well as prescriptive environment.
Andreas and Stefan, thank you both so much for that fascinating presentation. Are these your, let me return those to you.
Yes. Thank you, bye.
Thank you.